Hello, everyone. Welcome to our Approach to GMAT Questions segment. My name is Joshua Ubuya, a GMAT trainer and coach with the Kenya IELTS program. We'll bring you questions that are from the GMAT exams and show you how you can approach them in both quant and verbal sections. You check out our other videos to find out more. We would like to look at how mixture questions are approached in data sufficiency kind of problems in the GMAT exam. We've seen how it is approached, how they are approached in problem-solving questions. Now let's see how it happens in the data sufficiency problems. Before we get to the questions, we'd like to look at just a bit of recap on the data sufficiency methodology. This is because unless you know this, you may not be in a good position to answer the questions correctly. So what do you need to know to be able to address data sufficiency questions? This is just in general, not just for mixture problems, but just in general. Let's look at, first you need to know the concepts. What concepts are being tested in each question? That is one thing you need to be aware of. You need to know all the concepts. If you see a question that actually talks about properties or algebra, know all the concepts required in that question. Then next, you determine what constitutes sufficiency in this situation. For instance, many times you'll be given a question or a statement, and there will be an information which will be lacking that is required to help be able to answer the question. That is what would constitute sufficiency. You therefore need to be alert and be able to determine what will constitute the sufficiency of this question. Yeah. Before you got the statements, once you do that, then you can now go ahead and assess each statement independently. Yeah. Normally, this is one thing that people miss out on. You need to assess each statement independently, then together. First, to do it independently, the first statement, assess that question. Is it sufficient or not sufficient? If it is sufficient, then actually, yes, you can mark it as sufficient. If it is not sufficient, you can also mark the statement as not sufficient. Then next, go to the second statement, and then you proceed and assess it. Is it sufficient to answer the question given the parameters you put in place to determine sufficiency? If it is, you mark it as sufficient. If it's not, you mark it as not sufficient. Yeah. Once you do this, then now you can go ahead and select your answers. And this is what brings us to the third part of the methodology of selecting your approaches. What happens in the case the first statement is sufficient and the second statement is also sufficient, or the first is also sufficient, but the second is sufficient, and so on and so forth. And there are various options. Given the choices, you're normally told that the first choice you normally focus on the first statement. Statement 1 alone is sufficient, but statement 2 alone is not sufficient. That is one option you may select. Or vice versa, which is statement 2 alone is sufficient, but statement 1 alone is not sufficient. The third option is both statements together are sufficient, but neither statement alone is sufficient. Then D, each statement alone is sufficient. And E, statements 1 and 2 together are not sufficient. And therefore, you may need more information for any of them to be sufficient. That is what statement E turns out. So the biggest challenge students do face is the approach towards answer selection. So let's say you approach the first statement, you assess the first statement, and find it to be sufficient. If it is sufficient, then what you really do, you'll actually now cross off answer choices. Let's say you have answer choices A, B, C, D, and E, as stated here, as given here. If A is sufficient, you will cross out which answer choices? C and E. That is the first thing which you'll cross out. In fact, also B, because B says that the statement 2 alone is sufficient, but 1 is not sufficient. So these three choices will go. Whenever you find 1 is sufficient, the first statement is sufficient, the first 3 will go. So you're only left with assessing the second statement. And if it is sufficient, if 2 is sufficient, then actually now you cross out A and you're left with answer choice D, which says that each statement alone is sufficient. That is what you will go for. Yeah. And let's say now you go to, let's say now you assess the first statement and you find the first statement to be not sufficient. What do you do next? If the first statement is not sufficient, then what does that mean? It means that A alone is not sufficient. So you cross this one out. And at the same time, also you can cross. Will you cross E? No, you hold E first. You can cross A and D, yes, because each statement alone is sufficient. If one is not sufficient, so this one now it's not sufficient. Let's also just arrange our sessions. So yeah, so that now you can go back to selecting these answers. If actually one is not sufficient, yeah, then you go ahead and assess statement two. Before actually you go ahead, automatically statement answer choice A and D will be gone because that rules out answer choice. That rules out statement one in any place which it appears as sufficient. Now you go and assess the second statement and find it to be sufficient. If the second statement is sufficient, then you have to go for your answer that does B. Yeah, and rule out C and E. C and E. Let me rule them out. Yeah, so remember the answer choice B. If at all B is not sufficient either, or not B, but statement two is not sufficient. Yeah. So we looked at question one as statement one, not sufficient. And then statement two is not sufficient. If one is not sufficient, remember you had ruled out A and D. That was the first ones to go. And if the second statement also is still not sufficient, then rule out answer choice B. Yeah. And you're left with what? With C and E. You know, that's the point at which you try combining the two statements together to see if they would help in achieving the sufficiency which you are to assess in the question. If at all combined they are sufficient, then you go for answer choice C. Yeah, that means that both of them are sufficient, but neither alone is not is sufficient. If these are naturally, if you find that together they are sufficient, then you rule out answer choice E. And at this point in time also, if at all you find that both of them together they are not sufficient, what happens? What happens is that now you'll rule out answer choice C and you end up having answer choice E. So if at all actually find that together they're still sufficient, then you'll rule out C and the answer choice remaining is only E, and E becomes your answer. This approach needs to stick in your head throughout. Do not ever change this approach at any given point in time. Yeah, so this is what you need to do. So now we can dive into the questions and see what we need to do with each question and how do you approach the question now that you know what the sufficiency is. Now let's go ahead. There's a question here and I'd like to attempt this question. It's a sub 600 level question. These are questions which are not difficult to approach. They're quite easy and many people get them correctly. So let's take a look at this question. Then you can pause the video, attempt it, then come back and try, and then we can look at it together. Certain mixture of paint requires blue, yellow, and red paints in the ratios of 2 to 3 to 1, respectively, and no other ingredients. If there are ample quantities of the blue and red paints available, is there enough of the yellow paint to make the desired amounts of mixture? That is what the question asks, and the answer choices you have, the statements you have are that exactly 20 quarts of the mixture are needed and exactly 10 quarts of the yellow paint are available. So given this one, will it be sufficient or not? Pause the video, give it an attempt, then come back and resume it, resume playing, then I can see together. If you look at this question, it's talking about a mixture of paint, which has three colors, which is blue, yellow, and red. Then you're being told that they have their ratios of 2 to 3, 1. That means if you are to convert them to fractions, it will be 2 out of 6 for the blue one, 3 out of 6 for the yellow one, and then the red 1 out of 6. That will be the fraction of the mixture for each paint. Then we're told that we have ample quantities of blue and red paints. These are enough. These two are enough. But the yellow one, it's not enough. You don't know. Yellow one, not known. You don't know. So you can't say it's enough or enough. Now being asked if at all there is enough of the yellow paint to make the desired amount of mixture. So the question is asking us if there's enough of the yellow paint. One thing else I was to mention was that in the types of questions you get in the data sufficiency, they're either yes, no questions. Then what is then the amount or a quantity or and a definite answer, just one single answer, one answer, let's say. In the first section, in the first type, we'll have either it's continuously yes, continuously no. And then in the one answer, it has to be one unique answer. If you can get to a single unique answer, then that will define sufficiency. And in the other case, if actually can determine if it is continuously yes or continuously no, then that would amount to sufficiency. That was what given the two question types. To dive more into this, you could get into a training program and you get to see more, but it will just do more studies or reading on your own. Let's say. So let's see. Let's now get back to the question. We're being asked if there is enough of the yellow paint. So this is more or less a yes/no question. Yes, there's enough, or no, there's not enough. So if you can continuously get the answers yes or continuously get the answers no, then you have the question responded to. Then you have a sufficiency determined. So we need to find the quantity of yellow with respect to the rest of the paint. That will be our sufficiency aspect. And that is what we need to do before we can be able to go to the answer choices. So let's now take a look at, let's now get some more space and work on this and see. So the first statement you're assessing is statement one. You can choose either of them, doesn't really matter, but you just go with statement one. It doesn't harm. Statement one. Exactly 20 quarts of the mixture are needed. So what this is telling us, we have a mixture, we have the blue, yellow on the red one, where we had 2/6, 3/6. Then this one is a 1/6. So which means we need to get a quantity for us to be able to determine what this is and to get a quantity. And the quantity for all the mixtures or either of them. If we can get a quantity of all the mixtures, then also we need the quantity of yellow itself. So we need two values to be able to determine sufficiency. What is the quantity of the whole mixture? QM and QY. What is the quantity of the whole mixture? What is the quantity of yellow itself? Are we able to get the quantity of yellow given the mixture? Are we able to get the quantity of the mixtures given the either of the values? So that's what we need to determine. So we've been told that the whole mixture, we need to get 20 quarts of the mixture that are needed. So in all of them, we need to have 20 quarts. So B plus blue plus yellow in terms of the mixtures plus red will be equal to 20 quarts. If you get the values of blue, yellow, and red, then you get 20 quarts. So what we know, given the statement we have, is that we have enough of yellow and blue. We have enough of that to make it actually to be able to give us the 20 quarts. So that if you have enough, then what does that mean? If you have enough of blue and red, that means you have 2/6 times 20, the blue one. Then also the red one, we have 1/6 times 20. But does this tell us what we have for yellow? Yellow unit is a sixth. But we don't know, we've not been told. This statement doesn't tell us how much of yellow we have. It will tell us of the quantity of mixture. But it doesn't tell us of the quantity of Y. For that reason, we can't really determine exactly. Now, yellow should be 3/6, not 1/6, 3/6, sorry. So that we can't tell exactly what we have for the yellow mixture. And this statement won't be sufficient. So given that, you can say one is not sufficient because we don't know what yellow is. We only know what blue is, red is, and the whole mixture. They need to tell us what yellow is for us to be able to know if it is sufficient or not sufficient. Because yellow could be any amount. It could be any amount. It could be more than half. It could be less than half. So in either case, it won't be continuously yes or continuously no. So this is not sufficient. And therefore, they go to the next one. Since given that one, you can maybe have our answer selection sheet B, C, D, and E. If actually this is not sufficient, if you rule out A, rule out also D. So it will be left with B, C, and E. So exactly 10 quarts of yellow paint are available. So remember now our determining factor, we need the quantity of mixture and quantity of yellow. These are the two values you need to be able to determine sufficiency. So we've been told in this statement that we have 10 quarts, 10 quarts of yellow. We're not being told what is the quantity for the mixture. We don't know. Yet you have enough of the red and blue. That's what you've been told. We have not been told if you have enough of 10 of blue, of red and blue, how much do you have of the whole mixture? So the second statement only tells us that we have 10 quarts of yellow paint, but you don't know the mixture. What if the mixture has more than half? It could be yes. What if the mixture has less than half? It could be no. What if it's any value? So it can switch between yes and no. If it can switch between yes and no, then it's not sufficient either. So this one also makes it can say it's not sufficient. And therefore we rule out this answer choice B. That's image 2 alone is not sufficient. The one alone is not sufficient is sufficient, but one alone is not sufficient. That's the first statement we ruled out. And the second statement is two alone is sufficient, but one alone is not sufficient. So with these two ruled out, now we're left with the answer choice C and E. So if you combine these two together, what do we have? We do have that total, the quantity of mixture is 20. Quantity of yellow is 10. So you have these two, and you have 10. So if you have two, then actually you can tell that already for blue, what do you have? We have actually 2 out of 6 times 20. For red, what do we have? We have 1 over 6 times 20. And then for yellow, we do have 10 quarts. And 10 is actually just half of what it is. And of course, also do have that for the ratios, 3 out of 6 is actually 3 out of 6 is the proportion of the mixture that forms yellow. Because it is 3 out of 6 times what? Times 20. The 2 will go here 3 times, 2 will go 3 times, 3 will go here 10 times. Yeah. So 30 divided by 2. 3 out of 6 actually not 3 and 3. 3 and 3. So we have 10 quarts to be the desired amount for 10 quarts with the desired amount required to make the mixture. And which also matches what we've been told. So we see that C is actually sufficient because if you combine those two statements, we do have actually the desired mixture. So C is the answer, then we cross out answer choice E. So C is the answer. Yeah. So that is why that is not the methodology that is applied step by step. This question will be difficult if you don't know the step-by-step approach. But if you do, it becomes fairly easy on approach because what you need to do is just determine sufficiency. Once you determine the sufficiency, then you can go ahead and select. So go and rule out the answer choices and select your answer, the end of it all. So we see that answer choice C is the answer. Both statements together are sufficient, but neither statement alone is sufficient. This is arrived at after assessing each statement alone, as you had seen in our methodology.
You're watching Success with Bob Mwiti Show, presented to you by Upstack America. Upstack America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstackamerica.com. Upstack America, we wake you up to the unlimited potential.
So let's look at another question. A bartender mixes drink A with drink B. If drink A contains 24% alcohol, what percentage of mixture of drink A, what percentage of the mixture of drink A and B is alcohol? Yeah, there is a question we've been asked. Then the ratio of drink A and drink B is 1:4. The alcohol concentration of drink B is 1.5 times greater than the alcohol concentration of drink A. So these are the two statements we've been given. This is a question. So pause the video, give it a shot, then you can come back. We take a look at it together. this question, as you can see, we have a mixture. So mixtures, you do have need to know how the mixtures get to operate. Need to know the concepts of mixtures and the ratios that to come also with it. So that's one thing you need to know. Once you know that, you can be able to take this question and address it. So being given that drink A and drink B are mixed together, A contains 24% alcohol, and we've not been told what B contains, but you've been asked what the other mixture of A and B has in terms of concentration of alcohol. So the answer choices, I think you can we'll just have them. Just you should know them by now. If you don't actually look at revisit them, let's take a look at this question now and work on it. So we need to first of all know what will determine sufficiency in this statement. So you have drink A and you have drink B. Then you have drink A plus B because they're combined. Then you have alcohol. I can call it what? Alcohol. And then you can also have no alcohol. Or let's say just water and A. So this is what you have. So with this one, yeah, let's see. We have drink A, we have drink B, then drink A plus B. So we have drink A has what percent of alcohol? 24%. So it is 0.24. Then drink B, we don't know. Drink A plus B, we don't know. So what is not alcohol? Whatever is not alcohol here is 0.76. We can't say it's another solution because we don't know how many they are. But you know it's 0.76 of this liquid is actually not alcohol. So being asked for what will the percentage of alcohol be, which means they're focusing on this row right here, this first row that we're focusing on. What will it be? It comes to actually the whole mixture. So to get to know what this one will contain, what the proportion of this mixture will be alcohol, we need to know, first of all, the quantities being mixed, so that you know the resultant quantity is what, and the concentration of each contribution of into the mixture. So you need to know this is. You need to know this. Let's call this X. We change the color of this pen. Blue. And call this X. Then call this Y. We need to know X and Y in terms of the concentrations. Then we need to know the QA and QB. This is because whatever mixture you'll get, if you're mixing 10 liters and 20 liters, we'll end up having 30 liters total. Now, depending on the concentration you have, the concentration of 10 liters, the concentration of 20 liters, they'll also contribute to the concentration of the 30 liters. So that is what you need to know. So what will determine sufficiency in actually knowing what percentage of the mixture of drink A and B is alcohol? So we need to know what is the alcohol content in this A plus B. That's what you need to know. What is this alcohol content? And to know that, if we can be able to determine what this X is, what concentration of B is, then we can be able to determine sufficiency. Do we get that? So if we can get to know what the concentration of liquid B is, then we can be able to try to determine if it is sufficient or not sufficient. So let's look at the statements now that you know what we're looking for in sufficiency. The ratio of drink A and drink B is 1:4. That is the drinks in total. So 1:4 converted to fraction will be A will be 1/5, is in the first statement. 1/5, and B will be 4/5. Yeah, that is the ratio of drink A to B. So which means that in this mixture, what we have is actually just have a whole mixture. We don't know what concentration of B is. We only know that in this whole mixture, if you add them together, we'll be contributing only 1/5 of the whole alcohol content. Yeah, only 1/5 of the whole alcohol content will be from A, and then B will actually have 4/5 of the whole alcohol content. So it could be a fifth times 0.24 plus 4/5 times X to give us what we need to get. But since it's not telling us what this is, it's not sufficient. We cannot answer the question. It can be any value. Yeah. If let's say concentration is 10%, that it will be a different value from if the concentration is 20% or 30%, and so on and so forth. So one is not sufficient. Yeah. And with our answer key B, C, D, and E, if actually 1 is out, then also D is out automatically. The alcohol concentration of the drink B is 1.5 times greater than the alcohol concentration of drink A. And the second statement, we're looking at the alcohol concentration of drink B is 1.5 times greater than the alcohol concentration in drink A. What does this tell us? This is that the concentration of B is actually just 1.5 times that of A. So what does this mean? It means that the concentration of B, that means the value of X is actually 0.36. That's what it is. That's the concentration. But does it tell us what the quantities? No. We know that actually this is a concentration. So the quantities that we'll have in each of these, we don't know how these quantities do mix together to form the mixture. If you have too much of A or too much of B, it will actually lead to a different alcohol concentration of A plus B. Therefore, this can give us multiple answers. Therefore, this also is not sufficient. Yeah. And so we rule out answer choice B and left with C and E, which means now C, either we combine these two statements and see if at all the two of them are sufficient in sort of addressing this. So if we combine these two, remember that the first statement said that the ratio of drink A to B is actually 1 to 4. So A is actually 1 out of 5, and then B is 4 out of 5. Then statement B, the second statement tells us that the concentration of each of them is this way. Therefore, this way, know that the concentration of this alcohol in A plus B, each of these now, given this mixture, which will be constant, no matter what value you take, since it's a fraction now, it means that they'll be having a constant contribution to the concentration. And therefore, it means that A will actually be contributing to, in mixture A plus B, we'll have 1 over 5 times 0.24, not 25, 24. And then plus now for B will have 4 over 5 times 0.36. And this will give you the alcohol concentration of A plus B. And therefore, this will be sufficient, giving us a concentration. So therefore, C is actually the answer where now both A and B are sufficient. Both A and B combined are sufficient, but independently they are not sufficient, as has been seen. Now, as we go much higher, these types of questions that are now viewed as 600 to 700 level difficulty questions, they're not so difficult. They are not at all. In fact, if you just are conversant with the methodology that is in place, you'll be surprised that you can be able to solve higher difficulty questions with ease, with the knowledge and the approach that is in place. So let's see that in action. So we've been asked here, how much water in grams should be added to that 5% solution of acid to obtain a 10% solution? Yeah. So you have how much, that's something being asked. That's now an integer kind of question, which means it requires one answer, one indefinite answer. So an integer, a definite integer. That's what we're talking about as a question. So the answer should be actually sufficiency will be determined by whatever will be able to give us one single digit. Yeah. If you can be able to get a single digit that can be able to define that will determine sufficiency. That is the first thing. Then the secondly, what are we looking at? How are we going to set up our questions to be able to assess the statements? And what criteria will we be using to determine the sufficiency? Apart from this, now, let's see. We've been asked how much water in grams should be added to that 5% solution of acid to obtain a 10% solution. So here we have water, then you have acid, which is that 5%, 0.35 acid. It's mixed together to form actually a 10% solution. This is an acid, then you just do that and mix together to form 0.1 into water plus acid. So this the concentration, the acidic concentration in this one, that what is contributing is 0. 0, 0. That's what we're looking at. So we need to find out what quantity do we have, what is the resultant ratio of water to acid in the resultant mixture. given that in the current solution, the current mixture you have only 35 to 65%. That is now 5%, 65% of the acid to water in the mixture that you have. Then you're adding 0 concentration acid to it. How much do you need of this 0 concentration acid to be able to get 0.1 concentration acid in the final mixture? So you set up an equation, and if we are able to find a value that we can plug in here and get a definite answer, then that is it. So which is W and A are quantities being used in this mixture. So these are quantities that you do have. But we'll actually just have it as ratios in the final mixture because we're just setting up an equation to address ratios. So let's go ahead and assess each statement with more space. So we have the acidic solutions you have from water is 0. And then from the acid, you have 0.35. Then let us to get what? 0.1 into water plus acid. That is the resultant mixture that you have, which is 0.1 concentration. So if we simplify this, we have 0.35 A is equal to 0.1 water plus 0.1 A. We simplify this equation, what do we have? We have, let's take A to the other side and have water remaining on this other side. We have A, we have actually this one taking 0.35 minus 0.1 is 0.25 A is equal to 0.1 W. Remove the decimal points, we'll have 25 A is equal to 10 W. So if we get the ratio of acid to water, water to acid, what do we get? Let's say acid. Okay, water to acid, yeah. Water to acid, W over A, what do we get? W over A, we divide both sides by 10 over A. Yeah, by 10 over A, we'll have water to, we'll have 25 over 10, right? 25 over 10, because that is water. W divided by A, then 25 over 10, yes, that will be it. So the ratio of water to acid, 2.5 parts of water will actually need 10, okay, 1.0 parts of water. Yeah, so 2.5, 25 parts and 10 parts of water. That's what the result of mixture really. So if we are able to get the weights of each of actually one of them, this one, especially of the acid, then we can get the quantity of water because now we'll just be able to solve the equation. So water will be equal to 25 over 10, 2.5 A. That's basically it. That's what we'll be looking at. 2.5 A is then now what will give us. So we just need to find the values which will give us the quantity of acid. Whatever the quantity is, we'll get the quantity of water that is required. It's in grams. So now let's look at our statement. Statement 1, what does it say? We have there are 50 grams of the 35% solution, 50 grams. So if you have 50 grams, then now just plug in 50 grams here, and then what? W is equal to 2.5 times 50. What do you get? That is 125 grams. And we have a definite answer, not multiple answers. This is sufficient. That is sufficient. Then I'll look at the second one. So if this is sufficient, then our answer choices A, B, C, and D, and E. See, we'll have, if A is sufficient, then actually rule out answer choice B, C, and E. Those ones are ruled out. So remaining within our answer choice D to C. If the second statement is sufficient as well, then D will be our answer. If it's not sufficient, then A remains our answer. The 35% solution, the ratio of acid to water is 7:13. Does it tell us of the quantity? So the ratio of acid to water is 7:13. It means water to acid to water is equal to 7:13. That means acid is equal to 7/20 of the solution, and water is equal to 13/20 of the solution. It's really telling us more beyond this, not really telling us this. In fact, let's look at it. There's no quantity that we can be able to infer from this one because we don't know what quantity we have, because the quantity will determine what will have, because this is what we plug into this equation of ours that we had determined earlier. We don't have anything to plug in. So it doesn't really tell us. It can be any volume. It can be 20 liters, 30 liters, 50 grams, 100 grams. And for each one, we'll have multiple answers. So this is not sufficient as it is. It's not sufficient. Yeah. In fact, let's see. The acid is 7/20. Let's say time. Let's convert to percentage, you see. Times 100. We are 35. 35%. It's just telling us what it is. So it's just cyclical. It's telling us, just giving us any new information. It's just cyclical. So these are rules out such as D and such as A remains to be the answer. Yeah, so this one is answer 1 alone is sufficient. And this is how actually would approach data sufficiency kind of questions that have mixture related in them. You need to just know the approach. Come back again, and next time we look at other questions that you would also follow the same approach, different approaches, or in various questions. Thank you and bye.